All right, welcome. Today is Thursday, September 17th of 2020. Thank you all for joining us today for the Water Quality Science webinar. This webinar will cover recent projects from the Michigan State University's Institute of Water Research. The Institute of Water Research is working with several partners, including the Michigan chapter of the Soil and Water Conservation Society, to address water quality concerns. The Soil and Water Conservation Society's mission is to foster the science and art of soil and water conservation in Michigan and the Great Lakes region. Next, on to our agenda. During this webinar, Dr. Jeremiah Asher from the Institute of Water Research will provide a project overview. Alaina Nunn from the Institute of Water Research will then present on engaging River Raisin farmers in a subsurface water monitoring program. A look into the applicability, efficacy, and need. A Q&A session will immediately follow Alaina's presentation. Just a quick note, Connor Crank's presentation will start at the conclusion of Alaina's presentation. Connor Crank from the Institute of Water Research will present on improving stream habitat in the Maple River watershed. A Q&A session will immediately follow Connor's presentation. Now for a few reminders. As previously stated, each project presentation will be followed by a Q&A session. Questions can be submitted at any time using the Zoom toolbar. All attendees' video and audio features are disabled for this webinar for privacy. This webinar will be recorded and available through the Michigan Soil and Water Conservation Society's website and the IWR website. Attendees' names will not be called out during the Q&A session and will not be included in this recording. Now for a few brief introductions. My name's Katie Drosha. I'll be your webinar host for today. I'm the Vice President of the Michigan chapter of the Soil and Water Conservation Society, and I'm a soil conservationist for the Kent Conservation District located in Grand Rapids, Michigan. Dr. Glenn O'Neill is our co-host today, and he will be handling the technical side of this webinar. Glenn O'Neill is an environmentalist scientist and GIS specialist at the Institute of Water Research. He holds a PhD in geography from MSU and leads modeling and web development activities for IWR. He also serves as the president-elect for the Michigan chapter of the Soil and Water Conservation Society. Next is Dr. Jeremiah Asher. Jeremiah is the assistant director at the Institute of Water Research and has an extensive background in geographic information systems, decision support system development, and natural resource management. His research focuses on web GIS application development. He has developed several nationally awarded assessment and planning tools for local and state governments. His most recent activities are focused on developing sensors for managing water and edge of field and floating wetland research. Jeremiah, thank you for joining us today.
Thank you, Katie. Thank you all for joining us this morning. I wanted to start by giving a little background about our institute. For those of you who are not familiar with the Institute of Water Research at Michigan State University, we're part of a national network of 54 federally mandated water research institutes. The institutes conduct research to solve critical state and regional water issues. So today we'll be talking about two creative approaches to address water quality and quantity concerns in Michigan. These projects specifically are supporting local, state, and binational efforts to reduce excess nutrients entering Western Lake Erie Basin, which are causing some of the harmful algal blooms we've been seeing, and also supporting research for sustainable water management in the Great Lakes. The first presentation focuses on a low-cost tile drain monitoring program that was supported by the Herb Family Foundation with the goal of improving the health of the River Raisin watershed and Western Lake Erie Basin. With this program, we're engaging the agricultural community with tile drain monitoring data collected from participating farmers and using that data as a feedback mechanism for farmers to make more informed decisions on farming practices and to inform decision and policy of state and local leaders. The second presentation highlights modeling and online technology to guide agricultural conservation activities that are promoting increased groundwater infiltration in the Maple River watershed. This was funded by NRCS Regional Conservation Partnership Program, and the technologies here can be used throughout the Great Lakes region to maintain healthy streams and support groundwater management. So thanks again for joining, and with that, I'll hand it back to you, Katie.
Thank you. So next up, we have Alaina Nunn. Alaina is a research assistant for the Institute of Water Research. Her work focuses on reducing agricultural runoff to Lake Erie through empowering farmers to make environmentally thoughtful decisions by giving them access to water quality data from their own tile drains. She has a background in biochemistry from SWCS, and more recently, she has received her master's in community sustainability from MSU. Alaina, thank you for joining us today.
Hi everyone, my name is Alaina Nunn and I am a research assistant with the MSU Institute of Water Research. And today I'm going to be discussing a project that was funded by the Herb Family Foundation called Engaging River Raisin Farmers in a Subsurface Water Monitoring Program, a look into applicability, efficacy, and need. So our project's location is in the River Raisin watershed. This watershed covers approximately 1,000 square miles, 75% of land use is in agricultural production, and contains more than 3,000 miles of artificial drainage systems. Additionally, this is the largest contributing watershed in Michigan to the Western Lake Erie Basin. Then the main takeaway from this slide is that if you look over here, almost 90% of total phosphorus loadings are stemming from non-point sources, which is not limited to just agriculture, but agriculture is likely a large contributing factor. And when we do look specifically at agriculture, we can see from this slide that both annually and seasonally, subsurface drainage is the largest contributor of both dissolved reactive phosphorus and particulate phosphorus, which makes this slide particularly significant as we're able to visualize the high percentage of harvest acres throughout the Corn Belt that require artificial drainage as a means of producing viable crops. So as you can see here, anywhere from 60 to 100% of harvest acres are using artificial drainage, where as much as 50% of phosphorus inputs can be lost through those drains. So for these reasons, our project has really focused on looking at water quality from subsurface drainage specifically, or tile drains, in the context of using that data to better inform farmers about the nutrient losses potentially occurring on their fields. And from this, we hope to not only reduce the amount of phosphorus leaving farm fields, but also increase the number of farmers adopting conservation practices while helping them to make more informed decisions, and additionally increasing the awareness and adoption of subsurface nutrient treatment systems specifically. So for this project, we currently have 6 farmer participants with 11 collection sites in total, 8 of those being field sites and 3 of those being stream sites. And within this map here, you can see that those 6 farmers are distributed throughout the same subwatershed. And this here is the south branch of the River Raisin. And we found from a modeling study that this is one of the highest contributing subwatersheds for dissolved reactive phosphorus, which is why we recruited farmers from this region specifically versus from other parts of the watershed that may not have had as high of nutrient losses occurring. And then this picture here is actually of one of our participating farmers who was really excited to learn about the process of collecting the water sample and wanted to actually go out and collect one of those himself. And then this slide here is actually showing one of 2 ways that we collect our water quality data. So this shed here was built by the Water Resources Monitoring Group, who has developed low-cost equipment that enables us to capture data points like flow, rain data, temperature, and images of fields throughout the year. And this equipment is currently set up on 4 of our 8 fields right now. And then this here is a close-up of a drainage control structure, which is inside the shed. And this is what allows us to measure flow throughout the year. This is also not to be confused with an automated sampler. We do physically send out weekly someone to collect the samples from a tile drain. And then for the water quality analysis, we have a partnership between Michigan State and Adrian College, which is conveniently located within the River Raisin watershed. And then through this partnership, we're able to drastically cut down on the costs associated with water monitoring. And we're able to do this by training students to perform the analysis in return for research credits. And in addition to this, as a quality control check, we send some of those samples over to our lab at MSU to check for accuracy of the measurements. So all in all, it allows students to get valuable research experience along with analytical chemistry skills while enabling us to obtain quality data in a cost-effective way. So in the past, we would give out one annual water quality report and then sit down with the farmers to both help explain the reports as well as get their feedback on what information they found valuable and what their overall impression of their water quality was. But now we're trying to send those out more frequently, actually, so at least 2 to 3 times a year. This also enables us to get more face time with the producers and get better notes on what's happening on their field throughout the year as well. So this image here shows what a page of their report would look like. And I've zoomed in here so you can see the graph better. So one of the graphs we show farmers is the concentration of DRP each time we went out to take a grab sample. And then we look at how those the average of those DRP concentrations changed over time. And additionally, we include this benchmark of 0.005 parts per million to give farmers a visual indicator of how frequently the concentration of DRP coming out of their drain is above the concentration that we see in streams that cause excessive algal growth. So although we can't determine from these averages whether or not a drain is responsible for algal growth, we can use this as a conversation point with farmers and as an opportunity for them to make improvements to their farm management. And then just to give you an idea of how these averages can be used, I included this graph here. So here we have data from 4 different years, and you can see how the DRP averages went down as farm management changed. So in 2017 and 2018, this farmer had mentioned in an interview that they applied more manure than they typically do, whereas in 2019 and 2020, they didn't apply any manure at all. So this has been really interesting to track over the years and see how differences in farm management can change those average DRP concentrations over time. Another data point farmers can look at is their total phosphorus. So here, farmers can see how each grab sample compared to 2 different thresholds. The first being this blue line, which shows at what concentration you'll see excessive algal growth in streams. And again, we do not use this value to determine whether a tile drain is responsible for excessive algal growth. It's meant as more of a visual to give farmers something to work towards, since there's still a lot we don't know about phosphorus thresholds from subsurface drainage. And then this red line here shows the concentration at which point sources are not allowed to discharge water from their facilities. So the goal is always to try and stay below this line. And then over here, farmers can look at their loading values as well as correlate those to rain events. So as you can see, each of these rain events, each of these large peaks here correlated with a rain event. And it was really interesting to see farmers kind of make that connection as to more rain causing increased nutrient loss. Then as another data set, we like to look at DRP as a percentage of total phosphorus, because we've seen from a study done in Ohio that these values have gone from an average of 11% in the 1990s to 24% in the 2000s. So we're trying to track that in this study as well. And here farmers can look at how their average percentage compared to other participants, but more information is needed here to determine the meaning behind these differences. So we'll need to collect more detailed information, like the exact fertilizer application rates, to better understand where these differences are actually stemming from. So then in these graphs, farmers can see if they're using nitrate at an optimum rate on their fields, and they can do that by seeing where their nitrate concentrations fall in reference to the blue and red line that you see here. So I'll actually skip over this slide real quick so that I can explain what those lines mean, and then we'll come back to those charts. So this here was a study done by Purdue that looked at nitrate concentration in tile drainage water, and they were able to determine if nitrate was being used optimally on the field based on what concentration they were seeing come out of the tile. So if the average concentration was between 10 to 20 parts per million, it could be determined that nitrogen was being applied appropriately. But if that value went above 20 parts per million, then too much N was likely being applied. So if we look back at these graphs, we can see that F5 is using an optimal amount, while F6 is actually below that optimum rate. But this may be a result of them having a drainage control structure, which would allow more nutrients to be absorbed by the crop, and there would be less nutrients coming out of the tile. So this doesn't necessarily mean that the producer should add more nitrate, but this is something that we should definitely continue to look into in the future, in future projects. So then the last thing I wanted to talk about in regards to the reports is that farmers who participated in this project found a lot of value in being able to look at other participants' results. So although all of these fields differ in terms of management, farmers were very interested in seeing how other farmers' loadings changed throughout the year and as farm management practices were adjusted. And I included this quote from Farmer 5 because I thought it captured this really well. They said, "I don't need to know who the farmer is. I just need to know what his practice was and what his results were. And mainly I would be interested in what's not working. In other words, what you don't want to do because the data shows that you're going to lose nutrients if you do it that way." And if we look at the graphs, we can see that flow can have a very large impact on loading, as we see here with F2. But this is a particularly interesting case because this tile drain is actually continuously draining groundwater because it has set the water table height in this location. Therefore, the risk for nutrient loss here is extremely high. And then the other interesting thing about this tile drain is that during the interview, it was realized that multiple fields owned by 2 of the participating farmers and 1 neighbor actually contribute to this drain. And I really like this example because it shows the complexity behind managing non-point source pollution and the importance of bringing farmers together. The 2 participating farmers actually sat together during that interview and talked about this drain specifically for nearly 30-some minutes before we moved on to another topic, just trying to figure out whose land was the largest contributor and what they could do about it. And eventually they settled on looking into getting a drainage control structure out there. But without this project, that conversation likely would have never happened. And then this chart is also included in each farmer's report so that they can go back and look at how other producers are managing their land. So they can look at acreage. They can look at what crops were planted, whether or not cover crops are being used, tillage practices, and things like that. But the goal would be to eventually add in much more detailed information. So now I'd like to get into the results of the interviews. So after each farmer has reviewed their water quality report, I meet with them for approximately an hour-long interview just to gain their overall impression of the report and find out what they found useful or not useful. And this actually could be a whole presentation in itself. So today I'm just going to share 3 of the major themes that were observed across all 6 interviews, which are the need for water quality data, the willingness to change farm practices, and then the sharing of information with other farmers. So for this part of the presentation, I'm actually just going to read you some of the quotes that I thought were really great examples of each of these themes. And these were really valuable in explaining why this project is important. So for the first theme, the need for water quality data, Farmer 6 said, well, I've read water quality articles before on water sampling and nutrient loss, and it doesn't seem as practical or as real. But when I know it's coming out of my tile, it's my field or my practices that are affecting it, that's what makes me more interested to see the data. So this is a great example of a farmer who has learned about water quality data through other avenues, but it wasn't particularly interesting to them until it was data coming from their own tile drain. And then here's another example from Farmer 2 who said, well, I guess you know with that algal bloom down there, and they're telling us we're the problem, we need some data to prove that we're not the problem, or that I'm not. I mean, you can say whatever, but unless you got some sort of proof, talk is cheap. So again, I think this is really powerful because this is definitely a recurring theme with farmers feeling frustration because there's no data pointing to one particular farm. Rather, farmers are being lumped together and being asked to change their practices with little to no proof that they themselves need to change anything to begin with. And for that reason, this participant felt that this type of data collection is really important. So the next theme we found from the interviews was the willingness to change farm practices as a result of having access to this data. And so this is Farmer 6 again, who said, I mean, you always wonder, you read these articles on cover crops and no-till and water control structures, and you always think, wow, I hope that works. But now I can see on one of my own fields that it is working, and I can take what I learned off of that field and duplicate it over my whole farm, all my acres. And so this is really fascinating because if a farmer sees that what they're doing works and isn't negatively impacting the environment, then they can take what might have just been an experimental field and duplicate that across their entire farm. And then Farmer 1 said, I would want to compare the different types of application that other farmers did and see not only the type of application, but the amount that was applied, and then how much of it escaped from some of the tile lines. So in other words, if another farmer was applying his phosphorus in a different way and it was still as effective as the way I am, but it was easier, I may incorporate that instead of the way that I'm doing it. So this is another example of a farmer wanting to compare what they're doing to what other farmers are doing, so that they can potentially make their farming operation easier while also helping the environment at the same time. And then the last theme I wanted to talk about was the sharing of information with other farmers. So Farmer 6 said, yeah, it's actually my brother-in-law that's also a farmer. We farm together some. We help each other out, and the water testing site is really close to his house. He asked me what it was all about, and he was really interested in the results because I know how he farms and he knows how I farm. We're opposite. And he was really interested to see if it affected the nutrient flow out of the tiles. So this is a great example of non-participant farmers kind of observing from the sidelines what we're doing and waiting to see the results to determine if it's something that they should be doing as well. So for my closing remarks, I just wanted to revisit the goals of this project and summarize how or if we've met those goals thus far. So our first goal was to reduce phosphorus leaving farm fields, and it's been really interesting having some of our farmers be a part of this project for as long as they have, because we've been able to track things like how their average DRP or total phosphorus or nitrate concentrations have changed over the years in relation to what they're doing on their farm. So in this example, you can see two farmers who have seen drastic reductions in what their average DRP concentration looks like during the spring rainfall months, so from March through June. And it's been really interesting being able to watch them kind of fine tune what they're doing so that they can continue to achieve these results. However, with the newer farmers who've only been a part of the program for 9 months or so, they haven't even gone through a full non-growing and growing season yet. So it's going to take some more data to help them understand better what's happening on their field and therefore what actions they should take next. And then for our second goal, we wanted to increase the number of farmers adopting conservation practices. So as I mentioned before, the farmers who have only been participating for 9 months, 2 of them wanted to see more information or receive more information about drainage control structures, but also wanted to see more data, see what's going to happen during this non-growing season. And the third farmer, who's also only participated for 9 months, was really content and happy with their water quality results, but would like to see what the coming year's data is going to show. And then for our 3 farmers who have been a part of this program for 4 years, one of them was very concerned with their water quality results, which led to them doing nitrate stock testing, manure composition testing, some gully repairs, and additional soil testing, which was really great to see. And then the other 2 farmers have and are participating in a lot of conservation practices already. So they've actually seen really great water quality results, and they're very content with those results, which is a really great thing because it means that these farmers are very eager to share their techniques with other farmers and kind of share their success story with others. And then our third goal was to increase the awareness and adoption of subsurface nutrient treatment systems. So to do this, we held a field day event where farmers could learn about floating wetlands, which is what you see in this picture here. And in addition to that, we created a promotional video about the floating wetlands and their benefits. We also always discuss the benefits of drainage control structures to the farmers that it would be applicable to. And we always encourage farmers to participate at events like farmer-led meetings and share supporting data from their water quality reports and share those success stories of what's been working for them on their farm. And then lastly, we wanted to help farmers make more informed decisions. And so I included 2 quotes that I thought summed this up really well. The first saying, "Without data like this, we have no idea how much is going out of that tile. When you look at the water, it just looks like clear water. You can't tell just by looking at it or even by how your crops responded. So without studies or data or monitoring, we have no way to know." And then the last farmer had said, "Also, that goes back to trust. We've learned to trust you, and seeing information several years in a row, it's helped us fine-tune what we're doing." And then these here are our partnerships. And if you have any questions regarding this presentation, my email is below, as well as our assistant director, Jeremiah Asher. His email information is here as well. And thank you for listening to this presentation.
Thank you, Alaina. So we have a few questions to start off with. For you folks who are joining our webinar, please use the Q&A text box to submit your questions and I will read them out loud. So question number 1, what solutions are possible to reduce phosphorus concentrations during intense rainfall in drain tiles?
Sorry, can you say that again? I can barely hear you.
Can you hear me okay?
Yeah, I can hear you better now.
So question 1, what solutions are possible to reduce phosphorus concentrations during intense rainfall in drain tiles?
Well, I mean, that's that's a little bit outside of my expertise, but I would say that one of the things we're encouraging farmers to look into is drainage control structures. These are really great for, you know, during that time of the year when you're having those heavy rainfalls. The purpose of those drainage control structures is to hold back that water onto the field longer. So it prevents it from going directly through the tile drain. It holds that water back onto the field so that any of those nutrients that were stirred up can be better absorbed by the crop. And it will hopefully help prevent, you know, large losses during those big rain events. But that's kind of the extent of what I know about that particular topic.
I can add in a couple additional ones with tile drain management. There's some studies with saturated buffers, which is taking kind of lateral flow from the drainage tile. And then there's also some filter media that's being put at the end of drainage control structures that absorb phosphorus. And some of our edge of field studies comparing no-till and conventionally tilled fields initially here have been showing that we have reduced concentrations of dissolved reactive phosphorus leaving the system through our no-till field. These are still some early studies and we're continuing to do that work, but those are a couple different options that are available to producers.
Quick comment. So those folks that are submitting their questions, please submit it to the question and answer text box, not the chat text box. Thank you. All right, so on to our next question. Alaina, do all of these monitoring sites have similar soil types?
Actually, yes, they do, which makes it a lot easier, because if they were completely different soil types, it would, I mean, it's already a little bit difficult with the farmers wanting to compare to each other's farms. I have to be really careful with explaining to them, you know, your farms aren't all the same, so it's a little bit like comparing apples to oranges, but it does help that the farms are fairly similar in size. They're all relatively close to each other, and they are all similar soil types, or the same soil type.
Thank you. Moving on to our next question. You had an estimate of pounds of TP lost in subsurface drains. You also know the cost of the pounds of phosphorus fertilizer. Based on these, have you calculated the cost of phosphorus lost through drainage discharge?
We have not made those calculations yet, but it's definitely something that we have thought about and could do for future reporting, yes.
On to our next question. Was this research and sharing of tile WQ data part of a watershed-based plan to restore TP impaired waters?
Not to my knowledge, it wasn't part of an actual watershed plan. Maybe Jeremiah knows a little bit more about that, but I don't think that it was.
I think the project supports you know, different aspects of watershed management plan in the River Raisin, but it was not part of the initial watershed management plan that was set up there.
Did you use the flow data to extrapolate loading, or how do you use the flow data that you're currently collecting?
So we have two types of flow data. When we're taking grab samples, we also measure the flow from that tile drain simply by timing how long it takes to fill a 500 milliliter bottle. But those sheds that I showed pictures of, those are actually calculating for the fields that those are on, those can calculate the flow happening throughout the year and not just one specific time period. So for those fields that have that equipment available on them, we're able to look at flow and loading data throughout the entire year versus just at a very specific point in time on that day that we went and collected the sample. So it depends on the field and if the equipment is available there or not.
On one of your slides, you noted that there was a % increase over time of TP. Do you think that this was caused by legacy effects or the possibility of increased tiling in the drainage system?
I mean, it could absolutely be a little bit of both. I think both theories support that to an extent, but I don't really know, or I can't speak to exactly, you know, if it was one or the other or which one it was. I mean, my thoughts are leaning more towards the subsurface drainage, but I don't have, at least I don't have data in front of me to support that it's one more than the other, but I think both are definitely a contributor.
Okay, I have a two-part question next. One is about impact assessment. So at the worldwide level, specifically in the United States, many studies, reports, and articles have shown that there is currently no consistent determinants of adoption of conservation practices. However, the most common impact factor is often positively associated with studies such as yours. And this is related to an increasing acreage area that's being reviewed. What do you think your expectations are for the future? Do you think there will be like a positive impact as we have an increased acreage area size?
I mean, I guess in terms of how this project works, I mean, with increased acreage, I guess that requires you needing to interact with less farmers, I guess. And so the more farmers that you can, you know, come to with this kind of information, or, you know, the farmers who have participated in this project, them being able to go out and tell other farmers what they're doing and talk about their success stories. I would guess that it's a positive thing, just because you have less farmers that you need to reach and less farmers that you need to convince. But it could also go the other way, whereas when you have, you know, more of these big ag type farmers with these large acreages, you know, if they're the types of farmers who aren't as you know, interested in this kind of thing, it could be more difficult to convince them that this is something that they should pay attention to. So I'm hopeful for the applicability of this project, this type of work in the future, but it's kind of, I guess, hard to determine that.
Thank you, Alaina. So that your answer will lead into the next part of the two-part question. So the willingness to change. So as you know, farm size, farm income, available capital, education level, access to information, and a positive view on environmental attitudes and awareness, social networks, etc. These are all factors to facilitate the adoption of a conservation practice. Do you have plans, or have you already classified, categorized, or ranked the different farmers in your network? So like say small, medium, large operations?
So we have kind of a little bit of a mix of farmers in our project. So we have two farmers that I would say are fairly, that fit into that category of, large acreage. And then the rest are more of these kind of small, these smaller farms that are becoming, less and less. There's just less and less of these small farms. But yeah, we're trying to get more farmers involved who fit into that category of, having really big, having a lot of acres and having really big operations, because it'll give us a better idea of, whether or not this only works for those smaller farmers, or if this will also work kind of across the board with those farmers that, have those larger operations.
All right, our next question. At this current state of the study, do farmers share some of the costs to do data collection and analysis?
No, they do not, but we have asked in previous surveys whether or not farmers would be willing to cover the cost for some of this, because we were thinking in terms of if this program were to expand, or how we would make this more available to a larger group of farmers. Would they be willing to cover some of the cost of it? And our sample size was too small for me to, say definitively whether or not farmers would, but of the group that we spoke to, which was probably like 5 or 6 farmers in a small group setting, all of them thought that the information was valuable enough to at least pay something for it, similar to how they're paying for soil testing and things like that.
And Alaina, I'll add to that, these, the farmers aren't paying for the analysis of the water samples being collected, but then, they do invest in the changes that they're going to do on their farm. So drainage control structures or modifying practices that they wouldn't have been doing otherwise. So this program doesn't support, cost share for conservation adoption. So the farmers invest in those based off of what they're seeing.
Mm-hmm.
All right, another question. Does this project aim to spread the use of this program to implement through governmental programs? And if so, would the plan to have willing farmers or landowners to share in the cost of the analysis?
We haven't really discussed expanding into including it in a government type program. A big part of why this program has had the success that it's had is because, farmers tend to be pretty hesitant as far as, government programs go. They don't like having to deal with a lot of paperwork. There's some, trust issues that come into play. And so we've had to work really hard as coming in as a university and as researchers to gain the trust of these farmers. And if we were to expand the program, I don't necessarily know if that would be the best route or not, but we haven't really discussed that in a lot of detail.
Thank you. Do we have any more questions for Alaina? I'll give a couple more minutes just to see if we have any more. All right, well, thank you so much, Alaina. That was a fantastic presentation. We look forward to seeing from you in the future.
Thank you, Katie.
All right, we are now going to move on to Connor Crank's presentation. So Connor Crank is the project coordinator for the Michigan State University Institute of Water Research. Her background includes natural resource management, wildlife biology, GIS analysis, project and grant management. Connor received her BS from Michigan State University and her master's in conservation biology from the University of Florida. Her current research and project focus on sediment and nutrient management, as well as building peer-to-peer farmer networks. Connor, thank you for joining us today.
Hi, Katie, thank you. I'm gonna share my screen here. Good morning, everybody. Connor Crank, and I am the project coordinator for the Institute of Water Research at Michigan State University. The IWR is one of 54 federally designated water institutes created under the Water Resources Research Act of 1964 and is supported by the USGS. The IWR is involved in a number of modeling projects exploring the impacts that modified landscapes have on groundwater recharge and is interested in the positive impacts that groundwater recharge can have on stream health. In this presentation, I'm going to talk about a USDA NRCS Regional Conservation Partnership Program project that's currently being offered through the IWR that aims at improving fish habitat in the Maple River watershed. The IWR, in partnership with the NRCS, is offering conservation funding through a 5-year Regional Conservation Partnership Program, or RCPP for short, for agricultural practices in the Maple River. These RCPPs allow the NRCS, conservation partners, and producers to work together to address whatever issues they want to target in their watershed. For this project, we're looking to improve fish habitat and water quality within the Maple River watershed through increasing groundwater replenishment and reducing sediment. Many of Michigan's streams are fed by groundwater, which provides those streams with a cool and steady base flow. Several economically and ecologically important fish species in Michigan and the Great Lakes region in general, such as different types of trout and salmon, require cool or cold water streams to thrive. Groundwater extraction competes for those flows and can also divert critical flows away, which negatively impacts those fish populations that rely on them. The increasing demands on agricultural production also have the potential to increase demands for irrigation and fertilizer inputs, which of course further aggravates the challenges to groundwater quality and quantity. The Maple River watershed is a tributary of the Grand River, and it drains into Lake Michigan. The upper portion of the Maple River watershed is nearly 80% agriculture, which provides a lot of opportunities for sediment and nutrients to enter those streams. The upper Maple River Watershed Management Plan identified sediment as the highest priority pollutant in the area, along with nutrients, temperature, and bacteria. Additionally, a number of subwatersheds in the Maple River are currently experiencing pressure from groundwater withdrawals, which compete for base flow in the streams. So one of the goals of this project is to try and return stream flows within the Maple River watershed to the original values that were identified in Michigan's water withdrawal tool. So in 2009, Michigan began tracking high capacity water withdrawals, which are just defined as any water withdrawal greater than 70 gallons per minute. And they are tracking those through the water withdrawal assessment tool. So in this system, the water withdrawal assessment tool system, about 90% of all of the withdrawal requests are for irrigation purposes. So in the Maple River watershed since 2009, there have been about 221 new withdrawal requests in the WWAT. And out of those 221 requests, 103 of them fell into what's termed Zone D, which basically means that they would require either a site-specific review or modifications to ensure that they wouldn't have an adverse impact on nearby fish populations. And I'll talk a little bit more about those zones here in just a second. I'll provide a little bit of brief background info on that water withdrawal assessment tool. So it was developed by the MDEQ, MDNR, USGS, and the IWR to assess the impacts of new high capacity water withdrawals. So it all starts with a user, or this friendly lady on your left here, who wants to propose a new water withdrawal. And this is all done within an online tool. So first, the user would navigate to the location of their proposed withdrawal using an online map within the tool. The user would then enter some data on the characteristics of that withdrawal, such as the depth, the aquifer, pumping capacity, pumping schedule, and so on. There are 3 main types of models that are running in the background of this online tool. A groundwater depletion model, a fish response model, and some stream flow models, which all work together to generate that output of an A, B, C, or D management zone for each proposed water withdrawal. So an output of an A or B zone indicates that that water withdrawal is unlikely to have an adverse impact on any of the nearby fish populations. Whereas water withdrawals that would fall within a C or D zone would require either a site-specific review or modifications. So once that assessment process is complete, the user would register their withdrawal, and that withdrawal information is then added to this accounting database that removes the amount of water being proposed in that new withdrawal from the amount of water within that sub-watershed. So how were those A, B, C, and D management categories established? That process started off with the state of Michigan categorizing all of its streams into 11 different stream types, which are shown in this map on the right. For each of those 11 stream types, they identified the characteristic fish populations and the thriving fish populations. So of course, as you remove some of the index flow from a stream, which is shown on the x-axis of the graph here, index flow is also known as base flow, you inevitably would lose some of your fish populations. So the DNR met with their stakeholders to determine what percentage of the thriving and characteristic fish populations they would be willing to lose. So you can see here that water withdrawals categorized as Zone A withdrawals have a reduction of 10% of the thriving fish populations. Zone B withdrawals have a reduction of 20% of the thriving fish populations. Zone C has a 10% reduction in characteristic fish populations. And then Zone D withdrawals are any withdrawal that has a greater than 10% reduction in characteristic fish populations. So how does this Maple River RCPP project work to accomplish its goal of increasing groundwater replenishment? One way that we do that is through trying to increase infiltration. Infiltration is basically just water soaking into the ground. Less than 1% of the Earth's water infiltrates the soil and becomes groundwater. So whenever you have a precipitation event, that precip is basically going to act either as runoff across the land surface that enters into streams, or it can act as evapotranspiration to plants. And then some of it will work its way into the groundwater as groundwater recharge, or into the stream as base flow. So in Michigan, the majority of streams are fed by base flow. So groundwater entering into a stream is about 52 degrees and occurs as a very steady, even flow. Overland or surface flow, on the other hand, comes off of the landscape and enters streams at an average of 70 to 77 degrees Fahrenheit, and it occurs in a much flashier manner, which can be very disruptive to fish populations. So here's a really simple example of infiltration and the impacts from pumping. So there's a precipitation event happening in this first blurb here. The little gray cloud is raining on the hillside. So some of that water is entering this system as groundwater recharge and base flow into the stream. If you add a water withdrawal in the form of a well, that withdrawal has the potential to divert some of that flow away from the flow that would normally be entering the stream. So those flows impact not only the amount of water that's contained within the stream and the lake or pond, but also the temperature of the water within the stream. And of course, different types of ground cover also play a major role in infiltration and groundwater replenishment. So a major component of this project is trying to change the types of ground cover on agricultural lands to improve groundwater quality and quantity. So this concept can be demonstrated with a rain simulator like the one that's shown here from North Dakota State Extension. So each of these 4 metal planters contain the same type of soil, but they all have different types of ground cover. So the water that goes off into those front jars is representative of runoff. And then the water contained in the jars in the back is the water that soaks through the soil and represents groundwater recharge. So you can see the bare soil in that first metal planter box right there has a lot of groundwater runoff in that first jar in the front, and then very little groundwater recharge in that back jar. And the overall water quality in the front and the back jars is much worse compared to the water quality from the other 3 types of cover. Summer water temperature also plays a major factor in fish development, survival, and distribution. So lots of factors would influence that temperature, including precipitation, evapotranspiration, infiltration, aquifer storage, aquifer loss, aquifer transmissivity. So while we don't have control over lots of the drivers of fish habitat, we do have some control over evapotranspiration and infiltration. We can control those a little bit by the use of different conservation practices. So what we want to do in this project is modify the landscape to help shape some of those drivers of fish habitat. So these are some examples that we pulled directly out from our project. These examples are all, going to be spatially explicit, and they were run through our models in real time. So farmer 1 here switched their 100 acres from conventional tillage to no-till, which resulted in an increase in groundwater recharge of about 275,000 gallons annually. Farmer 2 moved their 100 acres, or excuse me, 80 acres from a corn soy rotation to pasture, which resulted in a 4.6 million gallon annual increase in groundwater recharge. And then farmer 3 enrolled their 200 acres from conventional tillage, moved into conservation tillage, resulting in a 375,000 gallon increase in groundwater recharge annually. So as you can see, these shifts in management practices definitely allow the numbers for groundwater recharge gallons per year to really quickly add up. So now I'll switch gears a little bit and just talk a little bit more directly about the Maple River RCPP project itself and kind of how it operates. So we are now in our 2nd year of the project. It's a 5-year project all in total. We were contracted for a total of $1.5 million through the NRCS and partner contributions. And about 600,000 of those dollars are made available for financial assistance to producers. So the goal of this project is to use select conservation practices to improve infiltration, return stream flows within the Maple River to their original values within that water withdrawal assessment tool, and to help meet contaminant reduction goals for nutrients, sediment, and temperature, which were outlined under the approved Maple River Watershed Management Plan. We also want to try to quantify those reductions and model their impact on improving annual groundwater replenishment through infiltration. And ultimately, the goal is to improve water quality and fish habitat within the Maple River. So the goal is to have a 5-year total of 4,334 equip acres contracted into the RCPP. 155,436,000 gallons of water replenished, and 3,467,000 pounds of sediment reduced. These numbers were developed to help achieve the appropriate flows for fish habitat and reach those milestones that were identified and outlined in the watershed management plan. Initially, we were focused on just enhancing recharge, but in an effort to be responsive to feedback from our project partners, we revised the program in 2019 to break up the watershed into priority areas for recharge and sediment. So for those recharge priority areas, the criteria for those would be streams that are at a high risk for adverse impacts from water withdrawals. Those would be watersheds with cool, cold, or cold transitional streams. And then for the sediment priority areas, the criteria for those would be streams that are not in the recharge priority areas, of course. And those would be areas where the stream temperature tends to be warmer and the fish are not as sensitive to changes in base flow. So here's a map which shows those recharge and sediment priority areas within the Maple River watershed. The recharge priority areas are shown there in blue, and the sediment priority areas are shown in green. So here's the kind of overview of the process for how to get producers enrolled into this program. The eligibility process begins with a technician using the GLWMS, which is the Great Lakes Watershed Management System, to pre-screen applications. So the GLWMS is an ever-evolving mapping, analysis, and reporting system that's used to improve water resource management across the Great Lakes. That system allows users to do things like estimating non-point source pollutant loads at the field and at watershed scales. They can determine potential reductions in non-point source pollutants based on implemented best management practices, or BMPs. Assess potential increases in groundwater recharge based on those implemented BMPs. And then you can use it to generate PDF reports that contain field scale analysis results and detailed maps, and then use those results to track watershed improvements over time. So once that report has been put together in GLWMS using the information from the producer, the technician would sit down and talk with the producer about what options they have in terms of which of their fields are eligible, which management practices would be, most suited to them for those fields, and then what the funding opportunity would look like, what the dollar amounts would be. And then the technician would submit the application with whatever the technician and the producer decided to do. They would submit that to the NRCS containing that criteria and then the points that are taken from the GLWMS report. And that information would be used to rank the producer's fields in EQIP, and then the producer would be able to get enrolled into the program. So this is a list of the eligible conservation practices that are being offered through the Maple River RCPP project this year. Those include conservation crop rotation, conservation cover, critical area planting, drainage water management, filter strips, and lots of others like no-till or reduced till. As you can see, we are no longer offering drainage or irrigation water management plans. Those were offered in the first year, but they are now contracted through regular EQIP. Additionally, cover crops are available as an eligible practice only in those sediment priority watershed areas. So to wrap up my presentation, we just want to thank all of our project partners for being so instrumental in making this all possible. And then, of course, thank you so much for watching, and please feel free to reach out to me or any of my coworkers at the IWR. Our contact information is listed here with any questions that you might have about this project or other projects we have going on at the IWR. Additionally, there's lots of helpful information about this Maple River RCPP project available at its website, which is www.maplercpp.weebly.com.
All right, and then I am happy to answer any questions.
Thank you, Connor. All right, so we have a question. How was the amount of groundwater recharge on the different land treatments determined?
It was determined through modeling. Glenn, you might be able to lend a little bit more information on that.
Sure. So we developed a soil and water assessment tool, or SWAT model, for the Maple River watershed. One of the outputs of SWAT is groundwater recharge. And so we calibrated that model to base flow conditions. That a typical SWAT model calibration process, if you're focused solely on water quality, might be to look at an entire stream hydrograph, including all the peak flows. But to try and approximate what's going on with regards to groundwater in the model, we focused solely on days in which stream flows were dominated by base flow or groundwater fed stream flow. So we calibrated the model to those conditions. And then we ran a range of simulations of conservation practices and land cover change throughout the watershed to see how they affected groundwater recharge on a field by field basis. And those results were incorporated into the online tool that Connor referenced.
Thank you. For our next question, how can you link your project of improved practices that increase groundwater replenishment and reduce sediment as an input for marinating soil health? Excuse me, as for maintaining soil health, excuse me.
Yeah, I was wondering, marinating soil health. So, the goal of this project was really targeted toward water quality improvements, but in terms of trying to link that to maintaining soil health, I'm not entirely sure if we've really looked at that. Jeremiah, do you have any input on this?
Well, a lot of the practices that are being implemented that increase groundwater replenishment are often improving soil health, increasing soil organic matter, keeping water on the field versus running off. And so we haven't done direct correlation on those, but I think there's a lot of pieces that could probably easily be put together to develop the relationship between the soil health benefits and improvements with groundwater replenishment.
Thank you. Any other questions for Connor? I'll give a couple minutes for you folks to use the Q&A chat box. All right, well, thank you so much, Connor. That was a great presentation.
Thanks, Katie.
Well, thank you for everyone. This was a wonderful webinar. Thank you so much for attending. Just a quick reminder, a recording of this webinar will be available at the Michigan chapter of the Soil and Water Conservation Society's website, and also at the Institute of Water Research website. Thank you all so much for attending and have a wonderful day.